Hi, welcome to my seminar. Today's topic is design consideration for installing automated hematology analyzer BW-1000. First, we take a look at the brief introduction for the system. It's similar to the Sysmet Automated Hematology Analyzer XN1000 that currently used in private and public lab for every single hospital around the world. The reason why I don't introduce the XN1000 and change it to a BW1000 because it's kind of conflict with the copyright with the system that I currently work on. So the function of the automated analyzer is to perform a complete blood count, like normally a routine health check for like annually health check every year, which is like essential for diagnostics in any medical condition that involve with the hematologies like anemia, leukemia, and infections. A few seconds about me. I have a bachelor degree in medical lab science. I'm also a board certified medical lab scientist from American Society for Clinical Pathology. I also holding a California state license for California clinical laboratory scientist. I'm currently work for the Department of Veteran Affairs. For the position, I would not disclose since it's more like a public um, appointment. So yeah, I do have a lot of experience work with the automatic hematology and a lot of different kind of analyzers that really apply to the system engineering. Now we will get a look like overview about the content of today's seminar. First, the introduction, system informations, function, and integrated. Then the second part would be statement of work with all of the requirement, and the final will be a work breakdown schedule. Let's begin with the introduction. It's about system information and function. It's yeah, analyzer will respond to conducting comprehensive blood tests, including CBC, differential counts, and other hematological assay. For differential count, it's more like a differential between different kind of white blood cell that go through your bloodstream that for like neutrophil, lymphocyte, monocyte, those really affecting when there's an infection going on. For the essential components, we have like a system, optical detection system, electrical system, and a computer system. Also calibration and cleaning. Let we dig in the main course for today, statement of work. Summary statement of task. The project involving design, implementation, integration of an automated hematology analyzer within the lab environment. So we already could go through the function of the system. Um, the SOW is for the design, deploy and operational of the automated hematologies. Then it will enhance the efficiency, accuracy, and throughput of blood testing process in the laboratory. The scope include and not include listed at so for this SOW design and installation process, of the hematology analyzer, including hardware setup and software configuration, calibration, validation of the analyzer, development, execution of test protocol, training laboratory personnel, um, implement the LIS, and document of all procedure protocol and training material. For not include the we not gonna develop a new blood test, and this at OW is intent for the installation of the analyzer itself only. Task input requirement. So we had three different task input requirement. The first one is physical space preparation, coordinated with facility management is one of the first thing that we have to like look at, and the completion requirement 2 to 4 weeks before the scheduled installation. The space required, and it have to comply with the manufacturer installation requirement. For the laboratory information system integration, um, is we have to collaboration with the IT department. So in order to update or like work on the assistant LIS to ensure the compatibility with the data management system, it would be take maybe up to 2 to 4 weeks, depend on the IT requirement of each hospital. Like for public hospital like Medical City, they're using medical like Meditech or Baylor and Texas Health. They're using the Epic system. Those is really easy in terms of IT to set up and run on. For private, like for public hospital, like within the county and federal system, they're using a much older LIS system, and the specification and protocol of those is really hard to configuration. Some of them require a lot of access permission for data transfers, or the data format itself is really old. Sometimes they will develop back in the 90, that not really fit or compatibility with other different computer or like coding language. Staff training is also one of the much of the really difficult and long process. It will it would take anywhere from the beginning of the installation all the way to the end of the deployment. It will require a lot of training, like hand-on training, and develop and deliver a training program for each different laboratory staff. Some medical lab scientists, they don't work with the hematology, or they more familiar with the different analyzers. So that's part of the problem that we have to deal with. Also, comprehensive training material that would really have, and it will covering the operation, maintenance, quality control procedure, and safety protocol. Those will really have, and during the compliance and um, during the SOP development, or any different evaluation that require practice tests that can make the analyzer run in affecting like processively. For the second part of the SOW is about the reference to applicable specifications. A list of specifications that only familiar with the medical labs protocol, anywhere from the manufacturer's specifications to the industry standard and guidelines. Um, and one of the most important is the regulations of the government, like from clear CAP and FDA. Also, the internal laboratory protocol is really important too. It make up the every lab they have a different policy, so it like the design and process have to consider those. And then for the update, we do have like monitoring, document review, and implementation of update that will reflect to the last requirement that need to be done. Um, the third part about the reference applicable specification is about the accessibility. It will talk about document storage, reference, and update any guidelines, any paperwork, relevant documents that easy to access when the CAP inspection occur or when the government inspection that can that will have for the standard compliance. They will look at all the paperwork, all the tasks, including installation, calibration, training. That part of the quality control process that make sure the lab doing it right. For the deliverable design process of installation, I make a table that had the deliverable description, deadline, and the acceptance criteria for each deliverable. We can take a few look at the like operation procedure. It requires that we have to deliver it by paper or PDF file and the PowerPoint for training, like update standard operating procedure, the SOP. That because since every lab they had different policy, we will have to comply with those and also comply with the um, with the industrial standard and regulations like ISO clear cap and FDA like complete certification that display by paper and email, and of course the analyzer installation, the BW-1000 analyzers. For the deadline, I don't write out a specific day because it will decide by the kick up start. We'll talk more about this when we go to the communication by task. Also about the performance metric based on the task, installation report, calibration, validation report, training, integration, operation, no, and compliance certifications. They do have their own success criteria and measurement methods. It will be best to look at each individual and familiar with part. It's like part of the system engineer that create a better performance that will affecting like the overall of the life cycle process. So the milestone, this is what I'm really wanna focus on, like from the project kick up. Um, it will have the input, task input, and list all of the like for me it's more like a summary of the SOW that involved into the input, the task input, task description, and the week, like the deadline, the timeline for every milestone that need to be achieved. Since the SOW is is between the blood work in corporation and the hospital lab, um, the best way is to establish a communication plan based on the weekly task progress, which is like the communication go hand on hand with the task alphabet task. This task will be present in the work breakdown schedule also. Um, it will this one also lists the role and the task description, the timetable, fit with the milestone. It's like a connection for all of the part, each like important part in the SOW that since the system engineer is more like a overall design process, um, the best way to make it effective is by the communications. For the risk management, this is influenced by one of my previous class about financial risk. Um, this is a risk that the risk of that they listed all of the risk assessment based on the task input and the impact and the probability of occurrence, which depend on the different environment or the lab policy or any issues that we will see in the during the designing process and installation process. Also, it will list the migrating risk that we'll have to avoid all of the issue later on. I also put in a budgets and resource for the SOW. Um, this honestly, this is based on my previous class that I have more it have more detail on the costs that um, but it's still not really reflecting the real cost based on the hour like the staff hour that we require the engineering role, but it's give the idea that how each task input will cost and the description, also the resource allocation that for the resource allocation, I think it will be really focused on the availability of the staff that will support the installation process. So this is my work breakdown schedule based on the task input, which the level one is a project kick up, level two, and then level three. It will instead of a numeric step, I using the alphabet stats, alphabet step like task A, B, C, D to give an idea of how the WBS should be. This is the more detail about each task with the task description, the timetable, and the responsible role. This it go hand on hand with all of the um, all of the previous discussion. Few detail that during like task E, the V model applications should be applied for the system engineering. Also, the life cycle maintenance and support develop is one of the best to represent the system engineer role, since every 5 years they will require to change the analyzer for public lab, and for private lab it will depend on the life of the analyzer, somewhere between 3 to 9 years. So the life cycle maintenance and support develop is really important that will effectively reduce the time and the resource needed for every time that they require to design a new installation process. For reference, a lot of the work is influenced based on my previous course from Dr. Richard. Um, lot of information is taken from the book, and also the generated AI with like multiple unlisted and edit from. that it's really hard to keep track on, but like it's of the work is from like most of the work is so edited between the AI and user to make it like better to understand and focus on the system engineering method. Also, there's a declaration that I think it should be best to um, like to have for the AI enhancement in the future, that if we apply the AI enhance in our work, although that it should not be considered as a real life project because it will require a lot more technology in the future. And thank you so much for listening to the seminar.